beginner person on C++, or you come straight into design pattern? C++ and then design pattern. Let's go ahead with the decorator pattern. So this is a. Do you need to start?
Start.
So this is a little difficult one in the sense that the concepts are good, but you might not find a lot of examples. You might not find a lot of examples in which it is being used. So one of the reasons is that it's a little difficult to get it for the entire part of your project. So maybe it is applicable in some parts of it, but not for the whole project. So let's try to see what this pattern is. Again, what kind of a pattern it is, the decorator pattern. So it's a structural pattern. And the idea of this particular pattern is to add additional responsibilities dynamically. So we are talking about it's dynamically being added. So what's the other way of adding it? You could add it statically also, right? So this pattern decorator is particularly for dynamically adding it. And what kind of pattern it will be? We had class pattern, object pattern, and according to behavior, we had a structural, creational, behavioral. So what kind of pattern it will be? Why is it object? It's an object level pattern, that's correct, but why is it object level? The key thing is that we are adding the responsibilities dynamically. So that means you are deciding it at the runtime. And runtime, what do you have? Objects. So if it was a class pattern, it is more of decided at the compile time itself, or statically decided. Now, there's one more thing is that this particular pattern is supposed to be an alternative way of subclassing. So you're trying to extend whatever functionality you have available in the base class, but you're doing it at the runtime, and you're not using inheritance. Because that's object orientation, the fundamental principles are abstraction, encapsulation, then inheritance, composition, all those things are there. The first tendency will be to use inheritance. And we saw that in the previous example, Amit was explaining about the scheduler stuff. We had explosion of class hierarchy. So that's particularly one thing which we want to avoid in any kind of design. Because such a design is not flexible and it is not going to help us in managing all the classes. So how we are going to, what is this decorator pattern that we will explain with an example. So again, we are going to revisit the pizza pattern. It's lunchtime, but now that we know how to make pizzas, let's try to make it a little more better. So this time, assume this situation where you have 3 different types of crust available. So you have a thick crust, thin crust, regular crust, and you have lots of toppings options. You can add your own toppings, whatever you want. Now, what if I had to provide the customer with your kind of pizza? You can make your own pizza. So you're given these options of your crust available, and these toppings are available. You could choose either 1, 2, or 3, or any number of toppings. Or you could just get the pizza base with that cheese alone. That is also possible. So, is it possible in making a typical kind of pizza? Because there are times where you would say, okay, I want a veggie supreme but no mushrooms in it. Instead of mushrooms, can I add another one? Maybe black olives or something like that. If you keep asking for it, so you want a lot of customization to be done. So that's more of extending the functionality. So you have the basic pizza concept, and if you have certain toppings in it, but you're extending it or customizing it, and that's in a flexible way. And you want to do that in a runtime. Now, with all this complexity, the difficult part is, how do I do the billing? If I have to calculate the price for it, so I need to have separate charge for separate toppings. So either based on the amount of toppings which you use, or based on the type of toppings which you use. So that's our problem. How do we do the billing? And with all these combinations. And all this has to be at the runtime. So You can think about ways to do this. This is exactly the first tricky solution, which typically, if we had started with just the basic principles of OO. So you have, forget about this pizzeria manager because I just kept it for the previous example. We have, we know that again, we are going to make pizza. So we have an abstract class called pizza here. There's something known as price, one method price, which is going to compute the price of it. And you have different types of pizzas, right? And we had different toppings. So we created one class for each of those type of pizza because it provides excellent abstraction and encapsulation. With the price of each pizza based on the topping, it's available within that class. So nobody else comes to know about it. You have a flexibility to give separate pricing for each of those. Everything is fine. But the drawback is that you have so many of these classes. It uses the object-oriented principles, but it's still not flexible enough. That's the main part of it. And another thing is that for each of these type of pizza, you need to create a class if you were to use only inheritance. So if you are to add a different base or a different type of pizza, so if you add different base, all the topping combination you need to create. So there will be additional classes. So that becomes totally unmanageable. So how do we improve on this design? What's a better way? We want to reduce the number of subclasses. That's the main idea. So how do we do that? Any thoughts? You're too hungry. You want the solution fast. Okay, this is another way of doing it. So here you have the pizza, and I keep a number of pointers or a certain attributes which tells what kind of toppings which you're going to use for this pizza. So in this example, I had given only up to 3 toppings, which is typically allowed. Anything more than that, they don't bill it with a real a name. And I can have certain methods which checks each of these are present and then add up the price. That's just another way of doing it. And because I have 3 different crusts, I use these 3 different types. So the price is going to be different for each of those types. So I reduce the number of subclasses. Now I'm still using all those object-oriented principles. So is this a better design? Somewhat better, but still not flexible enough. How do we change all these things during the runtime? You still have all the. Well, there's one way where you can just keep changing this pointer. You can modifying it, and you can still get it. So it allows some flexibility, much better than the first type, but it still has a lot of drawbacks. So how do we improve upon this further? Well, there's one more drawback of the previous solution. Whatever you keep in the base class, all of it gets inherited. So you had 3 different toppings. Suppose you set it as like the individual topping names. If you kept it as vegetarian and non-vegetarian stuff, and each of them you are representing by one attribute. So all those pizzas which are vegetarian, that will also have the non-vegetarian if you're keeping in the base class. And another thing is that the base class becomes too heavy. And if you want to add a new topping or any of those, you want to have an additional one, you still have to go and modify the base class. So all these things makes it too heavy at the top. That's not a good design. So how do we avoid this, or how do we make this design better? If we can avoid this modification to the base class anytime we want to modify this, it will be a much better design. And we want to stop using inheritance to extend the functionality. That's a keyword. We can use inheritance, but we don't want to use inheritance to extend the functionality. We'll come to that a bit later. And remember that you can only inherit what is present in the base class. Can you inherit something else? Because all the common properties have to be moved up to your base class. That's why the base class becomes heavy. So clear about it? So we are trying to make that base class very lightweight. So we are trying to limit the amount of inheritance that we are going to use. That's the main idea about it. Now think about making pizza in a different way. So I can take just a pizza and I add one topping to it, add another topping to it. So that way I can make a pizza, right? So what happens, okay, first you had a pizza, you added a topping to it. Is it still a pizza? Right? It's a pizza with only one topping. You add another topping to it. You had a pizza with two toppings. You can go on and add any number of toppings which you want, right? And you are allowed to choose what topping you want. So you just get the base, plus then you keep adding to it. So can we follow this kind of an approach into our design? So if we have some design which can do this in stepwise fashion, and it keeps on decorating a previous one. So these are the steps. If we choose a particular base, we add one topping, and if the customer wants, we can keep on adding any number of toppings. And at the end of it, which we decide about the price, how it is, and how we decide on the price, that we will explain later. So each of these stuff, whatever we are taking here, that can be considered as decorating a base object. So you got a pizza, you decorate it with one topping, you're decorating it again with another topping. So in the decorator design pattern, this is exactly what we are going to do. So even after decoration, you're still getting another pizza. So the type remains the same. That's the key thing to remember. You first had a pizza, you added another object to it, so you extended it, you got a different object, but it's still, its type is same as this original one itself. So that's what we are going to do it in our design. So how will the implementation look? So this is an implementation which follows this decoration. So we had a base class pizza, and you have three these thin crust, regular crust, and any other crust which you want. That is inherited. I will come to that. We said that we want to use minimal inheritance and all this stuff. So we'll explain it, why we are using this inheritance and for what purpose we are using inheritance. And then I have another one. This was something not there before. I had a pizza topping, and in the topping I can have a different type, any vegetarian or any of these different types. So it still uses subclasses, still uses inheritance, but that inheritance is not really for extending it, because the whole purpose is that in decorative we say so that we want to get the same type. After decorating, we still want to get the same type, because only then it becomes transparent. If you were to get a different object once you add the topping, that will change the whole concept. So you cannot use this layered approach. You cannot use one product and then build on top of it another one. You can't keep decorating it. It's not transparent if you don't have the type matching. So that's one important aspect of this decorator pattern. The type has to always have to match. So even though this decorator object, if you have a separate hierarchy, you still need to follow it from the same base class to have a type matching. So you get this object, you can use any one of these child classes, take this regular crust or thin crust, you decorate it with one of these topping, capsicum or onion or anything, you still get a pizza. So the type is clearly matched. Now how do we differentiate between this and this? What is this special red line? What does this indicate? This is a composition. So can we have just a topping? That's not a pizza, right? But always a pizza with topping will have a topping and a pizza. So it has a composition. So it has each of this decorator or this particular class will have one pizza associated with it. And when we were doing the layering also, so we had a pizza, we decorated it with this one topping, and the topping has one pizza associated with it, right? You added another topping, second topping, and that also has only one associated with it. So what the second topping takes, it could be directly taking pizza, or it could be taking another pizza which had one topping. So you could use either one of this, the component itself or the component which is decorated. Either one of them it can use. Clear? So this is one implementation for our making pizza and then doing it. Now comes to the trouble of doing this billing. How do we determine the price for this? So how did we construct the pizza? We did that in a layered way, right? You took the base, you decorated with one topping, and you decorated with another one. So for determining the price also, you can use the same method. So you had a price associated with this, and you want to decide the price for pizza with topping 1. What it can do is, whatever is the price for this topping, you can add it to the pizza 1. So the price method of this, only thing it needs to do is add its price plus call like whatever it's composing of its price, and you can change that to any number. So that's how we are going to decide on the price for pizza with one topping or any number of toppings. So all that needs to do is just change that. So it is doing a delegation there. Clear? Any questions? Any questions on what the decorator does? We'll go to the why we do certain things in that way a little later. But are we clear about it? So this is the sample code. So I'm just explaining only the relevant portions. So we had a class pizza. There's this one method price, which is the common interface. Because everything is being derived from the pizza. So you need to define a particular operation there in the base class, and that will be the same can be extended in the derived classes, and they can provide an implementation for that operation. So price is in our case the operation, because we want to determine the price for a pizza with multiple toppings. So that price method will be implemented in all the child classes. Then this is the another particular crust, and it has a price associated with it. And here we have a pizza topping. So this is also derived from pizza, but the difference is that it contains a pointer to pizza. So this is on the right side, whatever we had. This is more like a decorator. So the topping is a decorator, and it has a pizza associated with it. So you can have another this implementation for that. Here, how we decide on the price. So it calculates there are some attributes which are there for it, keeping the price for the decorator, plus it invokes the method on the object which it contains. So it has my pizza, one pointer was there, and I invoke the price method on that. So I could change it to my pizza price plus price also, my price. So that order is not really strict. So you could add your functionality before you call the composed objects method, or you could add it later also. So that's according to your implementation. And make sure that the pizza topping always has one pizza by making sure that the constructor takes a pointer to that object. So this is just one way of forcing that you don't have any topping without any pizza. So those kind of situations we want to avoid. So how do we create an object? Now, how do we create one pizza with the two toppings or one topping? So here, look at this part. I create a new thin crust pizza, and I say that I want it with the capsicum topping. So this object, whatever I got, I'm passing it to the capsicum topping. That's a pizza with topping, which takes a pizza as a pointer. So you're just chaining it. So pizza with the particular crust, you're giving it your topping as input, and whatever it returns, you still get the pizza. So that's a pizza with one topping. If you were to use two, you can use two levels of chaining. I take a new thin crust pizza, I give it to capsicum topping, and I pass it on to onion topping. So this is how you create it. So this is one example of what the decorator does. Now let's go to some of theoretical details of this. So any questions on this? So what are the advantages of this solution? This one or just a second. Yeah.
So now when the price has to be calculated,
Yeah.
just to look is at two price, right?
Yeah.
And
So you invoke that like a price on this object only, whatever you created. So the implementations of each of this, it will add its price plus the base. So you have pizza 2, so the onion topping, that contains like something with the capsicum topping. So it invokes a price on that. So that will in turn be invoking the capsicum price plus the base pizza price. You will change that. I didn't show that here, but you can chain it and make that's implementation. Okay. Yeah.
Including the same previous and have the toppings on the other side and do it.
Yeah, that's fine. We had like one class for pizza, another class for topping. Bridge, okay, how do you want to have it? So you want to derive from this?
Influence of topping on pizza.
Okay, you keep a pointer to the topping here. So you can have multiple topping and then you want to use it in this way. So this will be somewhat like the bridge pattern. But what do we use bridge pattern for? So you still get a pizza, get a topping, you can dynamically change it. What do we use this particular one for? What was the use for bridge pattern and what was the use for decorator pattern? That was different, right? The bridge pattern separates the interface and it provides you the flexibility. So you're changing on one and it doesn't affect the second one. But that is not, although the solution might look very similar, that was not the intent of decorator pattern. It's one part. And second part is that to have an implementation like this, you need to have the code for this pizza. Only then you can add a pointer. What if this was in a library? You don't have the code for this. You only get know that there's something known as pizza. You want to extend it, but you don't have the code for this. So you still, to add this pointer or reference, you need to modify this class. You need to add a pointer to this and then you extend this functionality. So what you mentioned, that is extending the functionality through composition. So instead of having a derived class and then dynamically keep changing or statically keep deciding on that, not having the class explosion, you just provide a pointer, you keep dynamically changing the pointer. So that's property of composition here. But the situation where you don't have this available, you can't use the bridge or any other pattern. Okay? So such situations you have to go with a decorator. So is this like a decorator pattern flexible now? It's flexible compared to the previous designs. And the price, so that we are doing a delegation here. So the proxy or whatever earlier design pattern that we studied, so that was doing the delegation. It doesn't need to have too much of intelligence there. It can just pass it on to the object which it is pointing to. So the same thing we are doing here. The method, like a price which we were invoking on the pizza with topping, we were passing it on to the, we add a little bit, but we were always passing it on calling the other method, which on the composite object. Correct? We were calling it on the pizza or whatever it was containing. So we use composition as well as delegation in this decorator pattern. And claim that it avoids inheritance to extend the functionality. So is it true? We still saw a lot of classes, we still saw inheritance being used, but it says that inheritance is avoided to extend the functionality. So is that statement true? Because this is one of the most important property of this decorator pattern. Is this true? Or we said we want to avoid inheritance. Well, we are avoiding inheritance only to extend functionality, but we need this inheritance. So how is this functionality extended here? So, as I said before, it's through composition, not through inheritance. So that's what gives you the dynamic changing of this like a functionality. So why do we use this inheritance then? That's only to get the type matching. Because a pizza, anything class which is derived from if you have a derived class and base class can be treated the similar way, right? So one is a subclass and the other is a superclass. So we are not using inheritance to get a subclass or change the behavior. So inheritance was used in earlier examples or earlier designs where you have a base class, you have certain functionality, you derive from that, you have a derived class, and you extend the functionality by overriding certain methods. So there you are using inheritance to override the functionality or extend the functionality. But here in this particular decorator example, we are not using it. We do override, but we don't change that. So the extension happening only through the composition part of it. So that's like one thing you have to remember. So a lot of other design variants, it might look similar. Bridge case, like Amit explained, that the interface need not be same. But in the case of decorator, the interface which you are trying to, like this example, the pizza case, the price was one of the method which was being defined. This is the operation which we are trying to implement in all the subclasses. So the price, it has to be the same. In the case of bridge, it may be same or it can be a small part. The major steps are decided in the base class itself, and only the small parts of it, significant part of it, we are changing it in the subclasses. So that's the difference between bridge and this decorator pattern. So here the interface remains same, and every class has to implement it. And only this decorator object will allow that one composition, and it will allow exactly only one. That's another thing to remember. It will only contain one component in it. The decorator can take only one at a time, not more than that. So otherwise it becomes just an aggregate class which contains multiple ones. So that's pure composition. But here it is decorator pattern which uses two principles. One is composition and second is this delegation. So are we clear about why we are using this inheritance and how it is used only to do this type matching and not for extending functionality? Any questions on this point?
So it's already derived. There's a point in adding object again.
Because you
Generally speaking,
yeah.
either
So
we need to derive it
okay.
or need to have a object to utilize its function.
Yes.
But here we are already deriving, so all the method, all the variable, everything is accessible.
Okay.
Why do we need another object?
It again depends on what all methods we keep in the base class. We talked about keeping the base class light, not heavy. So if you were to use the inheritance to extend it, we have to put all the common ones into the base class. Right? Here in the pizza example, I need only to define the pizza, I need to define only the method of fries. I don't need to give anything like I want a spicy, any other attribute if I want to add, or any type of pizza, anything like size or any of those things. I don't need to add all those things into the base class. I can keep varying it, the shape. Instead of a round one, I need a square one. All those things I can change in the subclasses. So it's more flexible. And if once you are given a certain set of items, like I gave you pizza, I gave you a set of toppings. Now, how do you make it? You combine these. So these two are given in a library. And how do you combine this and how do you come up with making your own kind of pizzas? So making that flexible, and those two becoming, this class is like a combination of pizza plus a particular topping. I'm creating a new one at the runtime. And I can create any type, any number of toppings.
So that object can be one of the derived one also. That's the concept.
Yeah.
See this?
Yeah.
In this pizza point in Instagram will have a capsicum topping.
Yes.
Okay. Yeah.
I'm sorry, I didn't get the question.
No, I was just.
See, the object can be one of the derived one also.
Yes. Because
These are
only the
not-
type needs to be matched. If you look at the you look at this one, so this was a pizza with a topping. So which in one case it was an onion one, and the pizza with topping, the constructor was taking another pizza, and because this onion topping one is a pizza, the type is matched. So you can pass it on to, you can use that to chain and create another one out of it. So this kind of flexibility, otherwise if you had to use only inheritance, you need to have a particular class for that. And that is decided at the start, at the compile time. So you need to have a class defined for it, and you create an instance of that during your runtime. But here, given those set of objects, you are allowed to create it during runtime. You can create any combination, any number of such combinations. And it's possible that you can have a separate hierarchy for the topping altogether, separate hierarchy for the pizzas, and you can mix and match and make any kind of pizza you want. I want a wheat-based one. I need a wood-burn pizza. The process of making it. Any particular parameter you can change. So to have this flexibility, you will need it. Now there's another way to achieve this. So that will come at the end of it.
You can put the object diagram. That will have 3
Yeah.
objects lined up.
So this is the structure of the decorator pattern. So this is you will have one abstract component, and you have certain concrete components. So in our example, this component was pizza, and the concrete components. This is a concrete component, and there is a decorator. Concrete component was like a thin crust or the thick crust or the regular crust, and the decorator was pizza topping, and like we had like the concrete instances of decorators, and all of them uses the same interface, and all of them are derived from the same base class. And the decorator, the one which was decorating the pizza, will have one instance of component in it. Only one instance of component. In the regular composition, you had multiple instances. And this operation method, this has to invoke the method from whatever it is containing. So the component will invoke, if I have to invoke this operation on the decorator, it will invoke the same on the component which it contains. So here I was keeping a pointer, the pizza topping example, I had a pointer to pizza in it. So any method which I was invoking, the price, I was invoking it on the pizza also. Like this. So I had a pointer to pizza here. So this was the component and this was the decorator. So I was invoking the operation which was defined. I was invoking it on the component whenever it was being invoked on the decorator object. So that's what allows me to chain and extend the functionality. So clear on this?
At least we need to have concrete things. Can you go
And this?
to that implement page?
Yeah.
Yeah, here. No, next. Next slide.
Yeah.
So here,
Yeah.
we are giving new thin crust, right?
Yes.
So what if it does new capsicum topping and then new onion topping? So if it doesn't give any, client need to know
Yes.
how to implement, right?
Yes, that's
How do we prevent the
because that is the trouble with the language as such, not with the concept. The wrong usage, how do we prevent that? That's up to the languages. In Java, we had that final word which was preventing any overriding. C++ does not have an equivalent one. So those are differences within the particular language which you choose to implement. So here, the design pattern, we are just presenting a concept. We tell that a certain rules needs to be followed, but there could be misuses. So that's dependent on how good a programmer you are and how good your library is. If I am keeping a pointer, I had to make sure that I get the pointer or the pizza is always filled, otherwise it is not valid. So those kind of stuff is specific implementation issues. As you said, you have to make sure that we are giving another component. So we always give another component, and the component will always have one decorator will always have one component associated with it. So in my example, I was always making sure you can't create a decorator without a component. If you look at this, the only constructor available, or only one which I mentioned here, is pizza topping, which takes a pizza. If I make the default constructor private, I cannot create one which is just a topping without a pizza. I am forced to create a pizza object and then give it to this topping object. If I do that, then the situation which you mentioned, that won't arise. If I give one pizza with capsicum or onion, if I say that is ensured that a pizza is associated with it. So that's by preventing the empty constructor or the default constructor from being private. So that's what the language provides, that syntax. Okay. So here in this, these were the participants in this design pattern. So we have a component. This is the abstract class. So the job of this abstract class is to define the interface. So you are defining the interface, and all other classes, the decorators and the concrete ones, has to implement it. So this is one thing which differentiates it from the bridge pattern. The interface cannot be different, because you're looking for a transparent one. Even after you put a topping onto a pizza, you still want a pizza. You don't want a calzone. So the object has to be transparent, and it needs to match the type. And then we have a concrete component. The concrete component is the one on which the responsibility or the functionality is being added or removed. You could use that to remove also. That's also possible. If you had a typical pizza which was with 2 toppings, and you saying that I don't want one of them, I want to replace it with another one. So this design pattern provides a flexibility for it. So you add or remove the functionality during the runtime. And the decorator is the one which keeps a reference to a component and defines the interface to which it has to conform, so that the type is matched. In the concrete decorators, these are the class hierarchy which you can come up with, and that can be used to extend the functionality. Now the question is, when do we use this particular pattern? It's used not very often, but the situations where we want to dynamically change the responsibility of an object, and that too transparently. So transparent in the sense that even when you have a topping added, it's still behaving like a pizza. Right? You could pass it on as a pizza to another topping, that constructor, and it was taking it. So it doesn't really care whether any other topping is already present or not. And this is extending the behavior when the source class definition, it may be hidden or not available for subclassing. So it stops the base class from being modified. Now, is there any advantage in doing that when you don't modify the base class? So that part of class, if in your project or example, if you see that there's one class which is already tested and compiled, everything is perfect in that. So because you don't make any modification, you don't need to test it, you don't need to worry about the behavior of that. You're extending it, so you're only worried about making sure that the extended behavior is correct. Other times, you're just invoking the method which are provided in the base class. So it allows the reuse, and it avoids that modification to the base classes unnecessarily. Only a part of it, the new functionality is being added. So clear on that? Now, composition and inheritance, these are the two most commonly used ways in the object-oriented code. These are the two basic principles on which you build your classes upon. And it's very difficult often to say one is better than the other one. So each of them has certain advantage, each of them has certain disadvantage. It's up to your problem, the solution that you're looking at. You want a compile-time solution, you want a runtime solution. So very often we mix these two, composition and inheritance. But we use those for certain specific needs. Like in our case, the inheritance was used only to match, not to extend it. And composition was used to extend that functionality. And because the particular kind of pattern which we are using, there's no limit on the number of decorators that you can use. Because we have only exactly one defined for each decorated object. So we can keep chaining to any number as we like. And we can add the same topping multiple times. That is also possible. So such flexibility is there with this decorator pattern. And since we are adding all the functionality into we are keeping the base class, we are not modifying it. So that keeps the base class very light. And because we use delegation, that keeps the decorators also light. And it promotes like one policy called open for extension but closed for modification. So certain books might refer to it as that's decorator pattern as this. So what do we mean by open for extension and closed for modification? Because take this example. When we are given it as a library, this pizza, and we are given another library with this toppings. So can we modify the contents, or can we modify the behavior of pizza or topping? Can we go and change the code for that? So those are given as library. We can't change that. So it's closed for modification. We can't touch that source code. But can we extend the functionality? Can I create a pizza of my own using this pizza and then this topping classes? I can extend it, right? So that's the principle of decorator. Open for extension but closed for modification. Now talking about some related patterns. So this composite versus decorator. We saw that decorator uses composite composition. So we saw there's a composite pattern also before. So what was the composite pattern or part whole, which Amit explained in the previous class? Do anyone remember that? One major difference between composite and decorator is that decorator is a special case of composite, or it's a degenerate of the composite pattern. The composite pattern was something like you had this one abstract class, and you had different.
Please press any key on your phone to remain in conference.
Okay.
Nobody's there, so we can.
Yeah. This was the directory and the listing which you, the file and being directory and the files which Amit explained. So there was a root directory, then you had a file and certain things the directory. So finally the pattern was, it was an abstract, then you had more than one. Okay, the composite was also derived from the abstract class. This was the concrete items. And like another concrete class which had multiple instances of the space. So that was a composite. So here there was no limit on the number of objects which you are aggregating or composing of. But in the case of decorator, it has to be exactly one. So that's one major difference between decorator and composite. The structure diagram looks exactly same between decorator and composite pattern. But it's used for two different purposes. Now, composite versus adapter. So, what was the adapter class, adapter design pattern, and when did we use that? Yeah, it's a wrapper one, and it was changing. Then there was interfaces were not compatible. That's when we used the adapter. You had like one particular client which was having certain interfaces, and another library when you added it was having a different method. So to make these to work together, you have this adapter. So there the interface was being changed. Although the behavior was similar, but the interface was changed to match with one another. So in the case of decorator, it only changes the object responsibility or it's extending it, but it does not change the interface. We had price one operation defined in the base class, and that remains the same in all the derived classes. So that's the difference between composite and adapter. This is okay. Another one between decorator and strategy. So how we built the pizza was we took the base one, we kept on adding toppings. So we kept on decorating it. So this is more like changing the skin of a object. You just keep changing the skin and you keep getting a new one. And the same thing we could change by changing the internals. So I took a pizza, I added one to it. I'm not saying decorating it. I added one topping to it, I added another one, I kept on adding toppings to it. So that is something which a strategy was doing. The one changes the skin, other changes the gut. That's the idea behind these two patterns. And you can achieve almost similar stuff in strategy also. Like we give the example of tax calculation. One was India specific, one was Japan specific. And the base class had like a certain interface, compute tax, which was and according to the country, you were setting that whether the India one or the Japan one, and then we were computing the tax accordingly. So if you change the gut, you get, if your implementation is just changing the gut, that's more of a strategy pattern. Otherwise, it's a decorator. The difficult part in this is, how do we identify which can be, either between decorator or strategy, which one we can use, and which part of the code we can use. That's going to be dependent on your experience with the design. So if you have a certain portion of your code which you find that it's easier to extend it, you're going to have more of combinations coming and it's easier to extend it in this way, you would go for decorator. But it can be, getting your entire program or project which follows this decorator is going to be very difficult. Because most often only a small portion or certain portions of the code will be changed. Rest of the stuff is going to remain constant. So in those times, strategy might be more better. Because we said that in the strategy case, it's not necessary that you need to have all of this. We were doing only one, in the previous example if I'm taking, we were having only one type of tax calculation at any time. To one client there was only one type of policy applied. So you have all these classes, but at any time you are using only one of it. So in such instances, the decorator becomes an overhead. So you would go for strategy. But if you know that if you are having a combination of classes coming and then you're going to avoid that class hierarchy explosion, and you want those flexibility where you want to mix and match, then you have to go for decorator. So that's the difference between decorator and strategy. So any questions on this related patterns? So this has been like a lot on the theoretical part with a very less amount of code. But the whole idea was to get the concept of what is the decorator pattern and when to use it. Any questions? So that's all I have. These were the references. One is the head first design patterns, and the other one is the standard Gang of 4 textbook. And, any questions? Or now everybody know how to make pizza and then how to add toppings. All right. Thank you.